Dear friends, welcome back to this digital electronics lecture series. So in this video, we will discuss about the memory element. So what is memory element? Memory element is nothing but it stores the binary information. What is binary information that we know? Binary information means it contains the logic 1 or 0. So memory elements are basically two types based on the triggering that is suitable to operate it. So based on the triggering point of view, the memory elements are two types. One is called the latches and another one is called the flip-flops. So latches, what is the difference between latch and flip-flop? So it is categorized on the category based on which type of triggering they are used. So latch are operate with the enable signal, which is level sensitive. Level sensitive means this is the clock input or this is the input. Then based on this 1 and 0. So based on this 1 and 0, latches is operated. So this is enabled with the level sensitive. Now flip-flop are age sensitive. Means flip-flop are basically work when the clock is applied. It has a positive edge. So this is a positive edge as well as this is negative edge. So flip-flop will on or off means operate based on this age triggering, where the latches are level sensitive. So this is the basic difference between latch and flip-flop. Now this is the basic memory element which is made by universal gate, NAND gate as well as the NOR gate. So here the NAND gate is there. Here is also NAND gate 1 and NAND gate 2. The second input is the first output. Similarly, second output is the first input. So this is the feedback system are there. So this is called one latch. It is 1-bit memory element. We store the 1-bit memory element. So condition for the latches and flip-flop, the condition is that it is stored 1 bit at a time. It has a two output Q and Q dash. So Q is 1, then Q dash is 0. Means output must be complement to each other. If both input output are same, that state is not considered in the flip-flop or latch. If Q equal to 1, then it is called set, and Q equal to 0, then it is called reset state. So here Q equal to 1 and Q equal to 0, this one is set and this one is reset. Based on set and reset, it is also called SR latch or SR flip-flop based on the triggering chapter. If it is age triggering, then it is flip-flop. When it is level triggering, then it is called latch. So based on the S and R input, there is a possibility 0, 0, 0, 1, 1, 0, and 1. So let's first input 0 and 1. So this one is 0 and this one is 1. We know the truth table of AND gate, NAND gate. If input is 0, then definitely output is 1. So here 0 is there, so definitely its output is 1. And this 1 is come here, so 1 and 1, so it is 0. So we get the answer 1 and 0. Similarly, if input is 1 and 0, so this condition 1 and 0, so 1 and 0, so this output is 1 and this input is 1 and 1, 1 is 0. So we get the 0, 1, 0, 1. So here output is 1, so it is called set state. Here output Q equal to 0, it is called reset state. Now similarly, if the both inputs are 0, 0, both input are 0, 0, we definitely know that if an input is 0, then NAND gate will give 1, so 1, 1. So this state 1, 1, it is not defined, means it is not used in flip-flop. The third condition, if input is 1, 1. So input is 1, 1. we cannot predict the output of Q as well as Q dash based on this one input only. So here the output is nothing but the previous output. So if it is 1 1 here, so the previous input is 0 1, then we get the output previous 1 0. Similarly, if here 1 1, then previous output is 0 1, then we also get the output 0 1. This is called the reset and this one is set and this stage is undefined. Similarly, if NAND gate, there is a NOR gate latches are present, so here the NOR gate gives the output 1, input is 1, then definitely it will give the output 0. So first condition 1 and so S is 1, so S is 1 and 0. Here set and reset, set is here and reset is here. Here set is here and reset is here. So this is the important thing. So 1 and 0. So here it is 1, so we get the output here 0 and this 0 comes here, so 0 0 we get the 1. So 1 0 at that time we get the 1 0. Same output for the 0 1 we get the 0 1 and 0 0 0 0 at that time 0 0 we cannot predict. For the prediction we require the 1. So if two are 1 1, so both are 1 1, both are 1 1, at that time we get the answer 0 0. So if both are 1 1, then we are considering both output is 0 0 0. So this stage is here also undefined. It is not used. Okay, and here if both input are 0 0, so we cannot predict the output of Q and Q dash. At that time it is considered as the previous output. So here 0 0, then 1 0 is the previous state, then output is 1 0. Here 0 0, if 0 1 is the previous input, then output is 0 1. So this is based on that here 1 Q equal to 1, so it is called set state. So this one is set state and Q equal to 0, so it is called the set state. Okay, so this is the basic memory element which stores the 1-bit information at a time. Now based on that memory element, there is a flip-flops are different types of flip-flops are there. First flip-flop is SR flip-flop, second one is JK, third one is B, and fourth one is T flip-flop. So here SR flip-flop. So here the clock is input is T1. So this is clock input is T1. This is AND gate and this is QT and Q dash. So this is the basic latch, and based on that clock input, SR flip-flop is developed. So this is the latch, and this one is the clock input, and this is become SR flip-flop. So here 0 0 0 1 1 0 and 1 1. So when input is 0 0, so based on that previous latch information, we get the output equal to QT. Means previous whatever output is there, that output we get at the 0 0 inputs. Now 0 1, then QT 1 plus means this is next state, this is present state, this is next state. So we get the answer 0 and 1 0, then 1 and 1 1, then that state is not used, means it is undefined. So based on this is the truth table of SR flip-flop. Now based on that characteristic table. So for the characteristic table, the present input S and R and present state is QT. So 0 0 0 0 0 3 input means up to 1 1 1 0 to 7 possibilities are there. So when input is 0 0, based on that characteristic truth table, if 0 0, then output is QT. So whatever the input QT, same output is QT plus 1. So 0 0 once again here 1, so we get the 1. 0 1, so 0 1 at that time answer is 0. So answer is 0. 0 1 at that time answer is 0. 101010 at that time answer is 1, and 11 at that state the output is undefined. So here don't care condition means this two output is undefined. Now based on this characteristic table, if we want to develop the characteristic equation of the next state, so we are considering this one, and this one, and we are, and these two don't get value, and we map in K map. So here LSB is S, R, and Q. So 0 1 0 0 0 1 1 0. So first pair is this 1 1 1 1 1 1. So we get the 0 1 and 0 1. So here we get the R R dash QT, so R dash QT, and based on this four value, we get the answer S. So S. So QT plus 1 equal to next state is always equal to S plus R dash QT. So this is the characteristic equation of SR flip-flop. Now here SR flip-flop disadvantage is that when the both input are 1 1, we are not getting the output. So this is the disadvantage of SR flip-flop. To remove this disadvantage, the next flip-flop is made is developed with JK flip-flop. So here there is a two input J and K. So JK flip-flop is basically gated SR flip-flop which can an additional input, that is clock input. It prevents the invalid output that may be obtained when both equal input are 1 1. So here the clock input is given, but the additionally input is given here the QT and here QT dash. So QT and QT dash. So based on that, here QT is given and here QT is dash is given. So the characteristic truth table of JK flip-flop is nothing but the same as the SR flip-flop, 0 0 then QT, 0 1 then 0, 1 0 then 1. But when both input are 1 1, at that time we get the toggle output QT dash. Means previously QT equal to 0 and 1 1 input is given, then output is QT dash. So based on that present state, the characteristic table JK and QT, this is present state. So 7 possibility when input is 0 0. So QT is 0. So here 0 0. So QT is 1 1. 0 1 0 1 then 0 0 1 0 1 0 then 1 1, and both input are 1 1. That time we are getting the output as a toggle of 0 1. So here 0, so we are getting 1, and here 1, then we are getting 0. So here QT plus 1. So if we are develop the characteristic equation by considering this 1 1 1, okay. So JKQT. So the first two pair is, so here we are getting K dash QT. So K dash QT, and based on this corner one value, so we are getting J, and here 0 1 0 is common, so QT dash. So J QT dash. So this is the characteristic equation of the next state of QT plus 1 for the JK flip-flop. The result disadvantage of JK flip-flop is race around condition that we will discuss in our next video when we explain the master-slave JK flip-flop. So master-slave JK flip-flop remove the condition of the race around condition that occur in JK flip-flop. Now next flip-flop is D flip-flop. So D flip-flop, it means it has a delay flip-flop. It is also called delay flip-flop. So next state of the D flip-flop is always equal to the data input. So whatever input we given, same output we receive by amount of delay which occurs internally in the flip-flop. So D for every positive transition of clock signal, and D flip-flop can be used as a register, shift register, or some application of counter. So in our next to next video, we will discuss about the shift register and counter. So here same JK flip-flops are there. So internally this is J and this one is K. So input is given by this inverted NOT gate. So one input is 1, then another input is 0. If this one is 0 and this one is 1. Now this is the truth table of D flip-flop. Truth table is D flip-flop. The flip-flop is always work with the positive transition, means there is a 1 is there, then and then we get the output. When clock is 0 and any value of 0 and 1, we get the output Qn. Okay, now 1 is there and input is 0, we get the output 0, and clock is there 1 and input is 1, at that time we get the output 1. So whatever input is there, that is our output. So now characteristics table, there is input and present state. So two variables, so four possibilities, 0, 0, 0, 1, 1, 0, and 1, 1. So when input is 0, the output is 0, input is 0, output is 0, input is 1, then output is 1. So by considering these two 1s, so it is nothing but the same as the D value. So Qn plus 1, the characteristic equation of the next state is nothing but the Qn plus 1. So this is the delay flip-flop or D flip-flop. Next flip-flop is toggle flip-flop, or it is also called T flip-flop. T means toggle flip-flop. So T flip-flop is the simplified version of JK flip-flop. It is obtained by connecting same input T to the both input of JK flip-flop. In D flip-flop, we are using here inverted NOT gate, but in the JK, in a T flip-flop, same output is given to the both the J and K value. So here J and K both are equal to T. So what happened here? So from this truth table, here also it is output is available only when clock is 1. When the clock is 0 and input may be 0 or 1, at that time Q equal to Qt. But when clock is given, at that time if input is 0, we are getting the output Qt. But when input is 1, then we are getting the output Qt dash. It means that if previous output is 0, then next output is 1. And if previous output is 1 and next input is 1, the output we are getting 0. So now here also the present input T and present state Qt plus Qt. So four possibilities 0, 0, 0, 1, 1, 0, and 1, 1. So if input are 0, so we are getting Qt. So Q0 and 1, 0 and 1. Okay, and input is 1, we are getting toggle output. So here 0, so output is 1, and here 1, so output is 0. Now based on this 1, it is nothing but if inputs are complement to each other, then and then we are getting the output 1. So it is nothing but the XNOR gate. So here Qt plus 1 is nothing but the T XOR Qt, or Qt plus 1 equal to T dash Qt, T dash Qt, or TQ T dash. So in this way, we know about the next state or the previous state, previous state output of the any flip-flop. So based on this knowledge, if there is a shift register or counter is developed, so we can easily identify which output is available based on the flip-flop truth table, characteristic table, and its characteristic equation. Okay, I hope you all are understand. In our next lecture, we will discuss about the master slave JK flip-flop and counter and shift register. Okay.